Reggie's Corner, we're going to look at special functions. This is our second day of this topic. So we're going to look a little bit with parent functions. In our next lesson, we're going to do more on parent functions, but we're going to talk about absolute value functions. Now, a parent function is the simplest form of a function of a family of function. So it kind of preserves the shape of the entire family. So there's a specific shape, like in this case, an absolute value. It looks like a V. And then you'll see there's going to be some shifting going on. It's going to get narrow. It's going to get wider. So with that, we know absolute value. We know whatever is inside, whether it's positive or negative, your result, your output's going to be positive. So if you look at this graph, and if I'm just graphing this, f of x equals the absolute value of x, absolute value of 0 is going to be 0. So that's where we're going to start. And then as we go to the positive values, absolute value of 7 is going to be positive 7. Absolute value of 2 is going to be positive 2. The same thing is going to be true on the other side. Absolute value of negative 1 is going to be positive 1. Absolute value of negative 3 is going to be positive 3, which is why we come along with this V-shaped. So when we're looking at our domain and range, our domain is going to be all real numbers because we can pick any value we want. And our range is going to be all non-negative. That's a way of saying greater than or equal to 0, because everything has to be above our y-axis. I'm sorry, our x-axis there, our y value has to be positive unless it's 0. So when we look at an absolute value function, it's a function that contains an algebraic expression with an absolute value symbol, right? So what we're going to start with before we're learning with our shifts and how things are going to be narrowed and such, we're just going to use a table. So I'm going to give you the table of values to start with because this is new for us. So all we're going to do is substitute in, and a lot of this you can do in your head. So negative 2 into, where x is here, 2 times negative 2 is negative 4. Absolute value of negative 4 is 4. So 4 minus 4 gives us 0. We'll do the same thing with negative 1. 2 times negative 1 is negative 2. Absolute value of negative 2 is 2. 2 minus 4 gives you negative 2. Now 2 times 0 is 0. 0 minus 4 gives us a negative 4. 2 times 1 is the absolute value of 2, which is 2. Minus 4 gives us negative 2. And then 2 times 2 is 4. Absolute value of 4 is 4. Minus 4 gives us 0. So although I set up here, and we'll go back to it kind of every now and then, that our output here is always going to be a positive, that's because our function is really only f of x is equal to the absolute value of x. What we did here is we did a couple things. We multiplied the inside by 2. We have a negative 4 outside. So we did kind of make some changes to that parent function. So let's graph it, see what it looks like. So I have negative 2, 0. And then I have negative 1, negative 2. And then I have 0, negative 4. And I have 1, negative 2. And I have 2, 0. I'll get my line tool and draw the line. And we'll put arrows on the end because we know that a line is continuous. Okay, so how did that change? Well, let's kind of look at the top at the same time. It definitely had a shift down, right? Instead of starting at 0, we started down 4. We'll look at this right here. That has something to do with it. It also looks a little bit more narrow, not as wide as our original parent function. And that is because of this 2x inside. So there's a shift that's going on outside, and how narrow, how wide the box is. The V is really inside the absolute value. So again, we'll talk about that as we go along. So our domain, again, is going to be all real numbers. Now let's take a look at our range. We have arrows going up, so we know that we're okay in this direction. We're going to continue. But our lowest value here is going to be negative 4. So we're going to write that in such a way. It says f of x such that f of x has to be greater than or equal to negative 4, because we're on negative 4, so we can include negative 4. Let's take a look at another one. And the same thing, I'm going to give you your x values because, again, this is new, so we want to make sure that you're understanding. So we have negative 2. Again, I'm going to plug it in here. Negative 2 minus 2 gives me negative 4. Absolute value of negative 4 gives me 4. Same thing with -1. -1 minus 2 gives me -3. Absolute value of -3 is +3. So we keep going. If I use a 0, absolute value -2 is 2. Same thing with 2. 2 minus 2 gives us 0. Absolute value of 0 is 0. And I have 5 minus 2, which is 3. You don't necessarily have to go in order, so I just kind of picked one out so it will look different there. 5 minus 2 is 3. Absolute value of 3 is 3. All right, so we'll plot that, see what happens. -2, 4 is here. -1, 3. 0, 2. And then we have 2, 0. And we have 5, 3. So although our numbers aren't in order in this one, I just want to show you that the shape is going to be the same. So I'm going to get a line here. And again, a line here. So I'm always going to have a V when I'm dealing with absolute value. Okay, so let's do domain and range, then we'll talk about the shape of it. So again, our domain, we could go left or right either way, so we're fine. So it's going to be all real numbers. Our range, now we're okay from 0 up, right? But not below that. So we're going to say, again, f of x such that, notation is important here, f of x is greater than or equal to 0. Now let's take a look at our parent function. Remember, started at 0. So we did a shift. We did a shift to the right. And that's because of what's inside there. The general shape looks about the same. And so what do we notice here? We notice that we shifted 2 units to the right. Okay, we shifted 2 units to the right. Let's go back to that first one. I believe I forgot to do that. What do we notice about that first one? And we did notice that we shifted down 4. We shifted down 4 units. We talked about it, I just didn't write it. And then we noticed that slope, it's a little more narrow. So the slope is steeper because that graph is a little bit more narrow, a little bit closer together. So that makes the slope a little bit steeper. All right, let's do another one, see how we do. Okay, so again, I gave you some values to work with. And let's go from here. So a -2 inside. So this one you have to kind of be careful. And if you need to write it, that's fine. -2, the absolute value -2 is 2. I multiply that by -1. So the absolute value of -2 is 2. Multiply that by -1, I get -2. Add 1, I get -1. Same thing. If I have the absolute value of -1 is 1, multiply it by that negative outside, gives me -1, plus 1 gives me 0. So some of them I can do in my head. Some of them it's just sometimes easier just to write it out real quick. Absolute value of 0 is 0. That negative outside has no bearing on it. So my answer there is going to be 1 because I have to add the 1 at the end. Absolute value of 1 is 1. Multiply that by -1. I get -1 plus 1 gives me 0. And then again, change that to a 2. Absolute value of 2 is 2. Multiplied by -1 gives me -2. Plus 1 gives me -1. So then let's graph, see what it looks like. And I have -1, 0. And I have 0, 1, 1, 0. And I have 2, -1. So it's definitely still symmetrical. This one looks a little different, which we'll talk about in just a minute. Let me just get my line there. I'll do arrows on the end. Okay, our domain again, that's going to be all real numbers. All real numbers. Because I can go left to right, no problem. My range, the highest value here, because this one's opening down, which we'll talk about, is 1. So the highest value I can have here for y is 1, or f of x. So I have f of x such that f of x is less than or equal to 1. What do we notice about this graph compared to our parent function? Well, we see that it's shifted up 1 unit. Shifted up 1 unit, right? It didn't start at 0. We also know that it's flipped. It's upside down. It's a reflection. So we're going to say graph is a reflection. And we're going to say it opens down instead of up. So let's take a look at our original function that we were trying to deal with. Well, we went up, and notice outside here there's a +1, so that has to do with the shifting up. Why did it go in a different direction? Why is there a reflection? It's because of this negative sign right there. So again, we'll look at this more in the next lesson when we're talking about parent functions, but this kind of introduces parent functions a little bit and talks about absolute value functions. Have a good day.